All right, so tonight's homework, today we're doing chapter 3 trig. This is 5 sections in 1 half-hour day. 3-1, 3-2, 3-3, 3-4, and 3-6. I'm not going to do any examples for 3-1 or 3-2. I'm just going to talk you through it real quick. 3-1 dealt with finding critical numbers. Critical numbers are where the derivative is what or what? Zero or undefined, right? So when you find a trig derivative and set it, you have to find where it's 0 or undefined. It's 0 where the top is 0, and it's undefined where the bottom is 0, right? Sine and cosine are always defined. Remember, their graph looks like this. They're always continuous, they're always differentiable. They can equal 0, but they'll never be undefined. Tangent, cotangent, secant, and cosecant, the cough is spreading. Tangent, cotangent, secant, and cosecant are undefined whenever you divide by 0. So, for example, tangent is sine over cosine. Whenever cosine is 0, tangent is undefined. Does that make sense? So, cosine is 0 at pi halves, 3 pi halves, so tangent is undefined at pi halves and 3 pi halves. Right, so you look at the function, say it's cosecant. Cosecant is 1 over sine. So wherever sine is 0, which is 0 and pi, right, then cosecant is undefined. Does that make sense? And you're welcome to rewrite the functions in terms of sines and cosines if that makes it easier for you to find the critical numbers. But that's 3-1 in a nutshell. 3-2 is mean value and rolls. You should still have that chapter 3 review chart that has all the steps for mean value and rolls. The steps don't change. For mean value, remember, you have 2 conditions. The function has to be continuous on the closed interval and differentiable on the open interval, right? And then for mean value, you find the slope of the secant, f of b minus f of a over b minus a, and set the derivative equal to the slope of the secant. For rolls, there are 3 conditions. What are the 3 conditions? Continuous on the closed interval, differentiable on the open interval,
have to be the same, like
f of a equals f of b. Endpoints have to have the same y values, right? Okay, and then for rolls, you just set the derivative equal to 0. All right, does that make sense? Okay, that's 3-2 in a nutshell. So for 3-2, you're doing mean value and rolls theorem with trig functions. 5 sections of homework sounds like a lot, but if you look closely, it's actually less homework than Monday. It's just a couple problems per section, right? Okay. Then we get, once we do that, we get into the curve sketching stuff, right? So increasing, decreasing, max, min, concave up, concave down, points of inflection, and sketch the curve. Which brings us to our first example, right? So, our first example says find everything and sketch f of x equals 2 sine x plus cosine squared x on the interval from 0 to 2 pi. Alright, so what's the first thing we have to do? Find the first derivative. Now remember, if it helps, rewrite cosine squared as that. Right? It helps you remember to do chain rule. Is that good? Okay? Okay.
You talking to me?
Sure.
Are you talking to me?
I'm talking to you. What's the derivative of 2 sine x? 2 cosine x. Alright, the derivative of cosine squared, you have 2 cosine x to the first times the derivative of cosine, which is negative sine. There were at least 2 quizzes so far where people got their derivatives right, and then in the next line, when they were multiplying by a negative, they dropped the parentheses and the multiplication turned into subtraction. Oops. Please be careful. Don't let your multiplication become subtraction, right? So what we have here is 2 cosine x minus 2 sine x cosine x. Will this ever be undefined?
no.
No. Sine x and cosine x are always defined. So all we're going to have to do is find the zeros This is a nice one. You should all like this factoring problem. What should we do? Factor out of 2 cosine x.
That's nice.
Oh, sorry, thank you. Okay. Alright, so we get 2 cosine x times 1 minus sine x equals 0. So to find the zeros, we get either cosine x equals 0 or sine x equals 1. Where does cosine equal 0?
Pi over 2.
Pi over 2 and 3 pi over 2.
Pi halves and 3 pi halves. You've got to know those. It's really going to be helpful if you know where things equal 0. So knowing those axes is going to be really important because you're finding zeros all over the place, right? So knowing those axis trig values are really going to help you. So x equals pi halves and 3 pi halves. Anyone know where sine is 1? At pi halves, right? So we just have those two values, bam. We have to make a sine line from 0 to 2 pi. Make sure you cut off your sine line at the endpoints of your interval. All right? So 0 to 2 pi, pi halves, and 3 pi halves. Now, this sine line is really easy because it's by quadrant, and so it's real easy to figure out the positives and negatives. I did one with first period this morning where there were a lot more critical numbers and you had to find angles in between all these intervals, and it became quite tricky. So I made it a little easier and for you guys. And the one on your quiz, I keep saying the quiz tomorrow, but Friday is similar to this. There's just going to be 2 critical numbers. It's not crazy. Okay? All right. So, all right. From 0 to pi halves, we want to know if this is our first derivative, if this is positive or negative. From 0 to pi halves, is cosine positive or negative?
Yeah.
Positive.
It's positive, right? First quadrant, right? Everything's positive in the first quadrant. All right. We have a gift with 1 minus sine x. Will sine x ever be bigger than 1?
No.
Sine x is always less than 1. So 1 minus sine x will always be
Negative.
Positive.
positive. Right? Okay, so this is always positive because you're taking 1 minus something less than 1, right?
Or 0.
Which is less than 1. Yes. Okay, so this is always positive. So now we're just dealing with the cosine, right? So in the first quadrant, cosine is positive. In the second and third quadrants, pi halves, 3 pi halves, cosine is negative. And then from 3 pi halves to 2 pi, cosine is positive. All right, so we're increasing, decreasing, increasing. I should label that this is an f prime sine line. And we can write our answers. So f is increasing on 0 to pi halves, union 3 pi halves to 2 pi. Why?
Would you put brackets?
I never do brackets for increasing, decreasing. I feel like when it's 0, it's not increasing or decreasing. But if you put brackets, it's fine, as long as it's not undefined at the bracket. So the College Board accepts either way. Okay, so why is it increasing?
Because f prime of x is positive.
Because f prime of x is greater than 0. Good. F is decreasing on pi halves to 3 pi halves. Why? Because f prime is negative, or f prime is less than 0. All right, where do we have a REL max? At pi halves, comma something. Why? Because it, what? Because f prime changes from positive to negative. And we have a rel min where?
3 pi over 2.
At 3 pi halves.
It's going to change from negative to positive.
Because f prime changes from negative to positive. How do I find the y values for my max and my min? Original function. So I go back to my original function. I have, what is the sign of pi halves?
4, 2.
The sign of pi halves is 1. So I have 2 times 1, which is 2. Anyone know what the cosine of pi halves is? 0. So I end up with 2. So I have pi halves, 2. Anyone know what the sign of 3 pi halves is? Negative 1. So I end up with negative 2. What's the cosine of 3 pi halves? 0. So it's negative 2. Alright, that okay? Alright. Let's use, how about this? You guys want to use this one for your f prime to do f double prime, or do you want to use this one? I'm thinking that one might be simpler. Either way, you're going to do product rule, right? Alright, everyone take a minute and find f double prime. Alright, I'm going to plug this in because the battery's about to die. You can talk to each other, check your answers.
I think that it's a bit unfair.
Just kicked the camera.
I think in the instructions you should have put all questions are worth whatever I want instead of all questions are worth 4. That would have made the quiz more accurate. Be like, all questions are whatever I want on my whim instead of all questions are worth 4 points.
Goes against the Geneva Convention. Human rights have been violated.
The Hippocratic Oath has been violated right now. If you were a doctor, you'd be doctor.
So you know the ICC taking you to the Hague is unjust. This is wrong.
What happened to like
Stalin wouldn't do this.
Stalin wouldn't even stoop this low.
Stalin would show university that was
Stalin would do like -5, 1 point above the acceptable amount of points to be.
I was right. Like this actually.
Jacob, did you do it?
Yeah.
Jacob, we're in strike right now.
No more, man.
Give me points or give me death.
I'm not gonna take it that far. I mean, like, I have like a future.
Okay, sounds like we're all done.
I'm not done. But I probably won't be in any. We're not done. We're doing school.
Okay.
Might as well start.
Alright, so let's do f double prime. Move this over. Okay. So I'm using the underlined function for my f double prime. So, and we have to use product rule. The derivative of 2 cosine x is -2 sine x times 1 minus sine x plus 2 cosine x times the derivative of 1 minus sine x, which is negative cosine x, right? The 1 is gone. Does that make sense? Did you all kind of get that?
Yeah.
Let's clean it up, see if we match. So we have to distribute. So we get -2 sine x plus 2 sine squared x minus 2 cosine squared x. So I'm going to factor out a 2, and then since we have sines and cosines, if this was a sine squared plus cosine squared, life would rock because it would just equal 1, right? But sine squared minus cosine squared does not equal negative 1. That would be negative sine squared minus cosine squared, right? So sine squared, yes?
I just have a question real quick. About the negative cosine x up there.
Yes.
You take the derivative of negative sine x, don't you? So
Right.
it's just positive?
Well, the derivative of sine is just cosine.
Oh, right.
Right. So that you don't change the sign.
Okay.
Yeah, Chandler.
Can you take out negative 2 and make that 1?
No, because if you take out a negative 2, you still have negative sine x sine squared plus cosine squared. There's no way to make one negative into two positives, right? So you're stuck with it. Now what you could do, which won't help you at all, is you could remember that cosine squared minus sine squared is equal to cosine 2x, right? Double angle for cosine? Of course, right? Okay, but that doesn't help us at all. So instead, what we want to do, if we need to factor this, which we do, is we need all of these functions to be the same. Since there's a sign here, I don't want to change the sign, so I'm going to convert my cosines to sines. How do I rewrite cosine squared so it's in terms of sines?
1 minus sine.
1 minus sine squared.
Oh, shoot.
You go home, dislike all your videos and surprise on
Is that okay?
subscribe.
Because we need them all the same or we can't factor it, right?
Right.
Okay.
Leave
So
some-
anyway, here's what we get then. So we get negative 2 sine x plus 2 sine squared x minus 2 plus another 2 sine squared x. So if we clean it up, here's what we get. We get 4 sine squared minus 2 sine x minus 2. And now, if we set this equal to 0, the first thing I would do personally is divide everything by 2, right? So you get 2 sine squared minus sine minus 1 equals 0. Now we have a very simple trinomial to factor. So we get 2 sine and sine, and we know we have a 1 and a 1. We want a negative, so we need a minus there and a plus there. So we end up with sine x equals negative 1/2, or sine x equals 1. Are there questions? I know it's kind of low. We're running out of space. I'm going to have to erase some in order to do the graph. All right, so if x is negative, if sine x is negative 1/2, well, what's the reference angle where sine is 1/2? Pi over 6, right? And sine is negative in which two quadrants? Third and fourth. So we get x equals, what's the pi 6 angle in the third quadrant? 7 pi 6 or 11 pi 6. And then also we need to know where sine is 1. Pi halves. Whoa, we've got 3. And one of them's kind of a toughie. Our f double prime sine line. Make sure you write these in the correct numerical order. Which one of these comes first? Pi halves. Then 7 pi over 6. Then 11 pi over 6. And then we end at 2 pi. All right. Let's find some signs, shall we?
Oh!
Okay. Now, here, let's just think about this for a minute. All right. Here we have the sign from 0 to pi halves. Pick any angle in between 0 and pi halves.
Pi.
I would go with pi over 6 because then the sign is 1/2 and it's easy, right? Okay. So if we plug in a pi over 6, we get 1/2, so we get 1 plus 1. Well, that's sure positive, right? Here we get 1/2 minus 1. That's negative. positive times a negative, or negative. Between pi halves and 7 pi sixths, what's the easiest angle to use for pi? Or for sine?
Pi.
Pi. All right, because what's the sign of pi? What's the sign of pi? 0, right? So we get 0 plus 1, which is positive, 0 minus 1, which is negative.
So it's negative.
Whoa.
Stuff like this.
I'll make sure I didn't make a mistake somewhere. Okay. Between 7 pi 6 and 11 pi 6, what's the easiest angle to use? 3 pi over 2. So at 3 pi over 2, the sign is what?
-1.
Negative 1. So I get negative 2 plus 1, which is negative, right? Times negative 1 minus 1, which is negative. Negative times negative is a positive. I don't know why this is bugging me. No, it's negative.
Maybe you're negative and just lower than the other one, so you
I
want
guess
to be on
so.
the same level.
All right. 11 pi 6 to 2 pi, that's a tricky one, right? Because there's no nice angle to plug in there. Here's how I like to think of it when you have to do that. So if we know, let's just pretend that like this is 11 pi 6, right? Sine is 0 here, right? At 11 pi 6, the sine value is -1/2. And down here it's -1. So the values of sine, since it's continuous, from 11 pi 6 to 2 pi, have to be between 0 and -1/2. Does that make sense? So you can just say, all right, well then let's just pretend that sine is -1/4 and plug it in and it will work. So 2 times -1/4 is -1/2 plus 1, this is positive. -1/4 minus 1 is negative, positive times a negative is a negative. All right, we'll continue from there. Tomorrow's a review day, so we'll finish this up, but you still have to do all